Hello. So with this screen recording, I will be performing a two-way repeated measures ANOVA, which is out of all my recordings the most difficult to do. And this ANOVA will be done on my dissertation data, specifically some VO2, well, volume of oxygen consumed data collected from some Douglas bags during my trials. Um, Specifically, I will have two within subject factors, my control and experimental, within as one factor, the condition factor, and my second factor is a time factor where I did data collection twice, one during the Wingate protocol that I used for my dissertation, and then I also did another um, uh, Douglas bag collection um, after that Wingate protocol during their warm down. So I'm gonna have two levels for both factors, condition and time. So to get started, like always, we need to open up the Jupyter notebook, close that, and here we go. And always open up a new notebook. Perfect. So first thing, like always, is I need to import the libraries that I will be using. So the ones that I always import, even though I don't use all of them, is I've copied them twice. Is a these guys, my pandas library, which is working with the data tables, my NumPy library for working with the helps with the math and numbers. The stats modules formula, which is used for running the statistical models and formula, but I won't be using um, that one. Um, I'll be using actually a different form from stats models later, and these ones are kind of just visualization, data visualization libraries. So I'll run that, and now I've imported those libraries. The next thing, like always, is I need to import the Excel document that has my data within it. So, um, like my other recordings, I call my new variable that will contain the data frame, contain the data within this Excel. I will call that dissertation so I can get it easier. Next things I need to always find the path, and you can see I'm using my VO2 variable data. Copy that path and there. I'm using the pandas library to read this Excel file. And actually, after this, we can view our data frame so that it looks correct. So yeah, as we can see here, uh, I've in Excel I haven't worded these the best, so later through this I will be doing some renaming. Well, actually after this I'll be doing some renaming of these variable names. But we can see here that I've got the control conditions, VO2 or oxygen collection during the Wingate. So this would be kind of first control condition, first time condition. Here control condition, but data collection during the warm down. So this would be first um, condition and second time condition, and then likewise for the rest of these. So this is now where we're going to try and import. Let me see if I've got um, the correct. Yes. Yeah, that one. So here I've got my well, I'm importing my libraries. So this is, I've just got this on my clipboard, but the main one is this one below, where I'm specifying from this library. I would like to run this repeated measures ANOVA test that is incorporated within it. Um, well, actually, this top one is actually just another part of this stats models library that I'm importing, and that makes my life easier trying to use this ANOVA RM, ANOVA repeated measures function later on. And next thing that I've got to do is, like I said, I want to try and these rename and assign subject specific columns to my data. Um, so first thing is what I like to, I've seen other people not have to do this, but I for some reason do, and it's I have to reload my data and keep specific columns in order to like rename them and use them later on. So all that means is I've got to copy this um, back here to kind of specify that this is what I want to do. Um, what I'm going to be doing is I've got to kind of specify that this is that these are in my local library, and I want to change within the local library. See, now we're kind of going ahead, so I'll bring this over here so it's more easily visible. But within this local library, I want to work and to rename this um, column name. I forgot to define them. And basically now I've just got to put in each one of these columns so that I can rename them afterwards, whilst remembering to define them. Otherwise, the software would not be able to find it, which is not good. Fully close it off. So now I can do my rename function, where I can now specify that for the columns of this variable's data frame, specifically, since this is actually going, gonna go further on, I'll just bring this over for us so we can view it easier. But the columns within that data frame, I want to change this column's name to, we'll just call it, so we can take off the VO2 at the end, because we don't need to actually specify, because we know it's about VO2. And I'll just go through, because all this is done is it's specified that I would like to rename, I'll use the rename function for the data within this variable's data frame, and specifically within the data frame I want to rename these columns. So the first one is the original column, and all this all these two dots do is specify that this will now be renamed as this. And I'm going to go through now and do each one of these, hopefully quickly. final column and rename it as just control one down. Well, that's not correct. I just realized I got my control wingate here, control warm down, experimental wingate, and this should be my experimental. So it's actually a good thing that I'm renaming this, because actually that should not be control, that should be experimental. So that this will actually fix that. So later on it makes sense. And this is why it's always good to actually preview your data frames by always just putting them here so you can rename them and make them easier. Just format everything, because you save yourself a lot of hassle here, especially with this Python coding where it's so sensitive to like syntax errors. And now all this assign function is doing is it's assigning a new uh, a new column, and it's assigning and making it so that we can see here it starts off at 0. I'm basically going to create a new column where it starts off as 1 and goes through like that, which we'll be able to see once I do a preview. And now we'll index it. Use the index function to add 1. Some of these things other people don't have to do, and maybe they can optimize it better, but for a lot of trial and error I've found out through research that I have to add some of these things so that later on other issues that I do find do not present themselves. So let's make sure that the brackets is closing off, and yes, that's good. So that's now assigned everything, and actually we now want to print it so that we can view our new columns, which sometimes I'm just able to do this, and yeah. So this assigning a subject to lambda is just saying we want to start this kind of row and be named as 1, 2, 3, 4 instead of kind of doing 0, 1, 2, 3, 4. And this way we can see that there's actually 8 subjects and not just 7 rows, which is helpful later on. Now the next bit is where we're actually going to start defining which variables are going to be used for the or how they will be used for the two-way repeated measures ANOVA, because defining the order and which variables interact with each other during the test is very important, and we don't actually have to usually think about it when we do a repeated measures ANOVA too much in other software like SPSS, but here we do. And to do that, I'm just calling my new variable with this new kind of data frame. I'm saying that I am using this melt function to kind of combine everything based off this new ID, new identified variable that I created, identified column I mean, which is my subjects column. This is kind of specifying that all the rows get melted in between. this is now just I'm specifying that my um, well, all this is actually really trying to do is I'm trying to change my original table from a wide format like it has right now to more so a long format. So it's easier to read and identify everything, which we'll see later on. I've found that a lot of the time it's you've just got to trust the process. Um, we'll make our variable, total variable being measured is the VO2, and I need to close that off. So well, this is, as I was saying before, this is actually more of a syntax error. And this is why it's so sensitive, is because I've put subjects when I've named my column as subject. So there we go. And now we should actually be able to see how it's been done, and this has just brought it out. So it's no longer, like I said before, kind of going across an x-axis. We're now having everything kind of go more like on a y-axis. And this is where we can easily interpret and see the data that's specified for each condition, experimental control condition and time condition. And now actually we can try and clean this up to be a bit better. So within my within my variable, I would like to assign some new columns so that I can specify them later whilst doing the test. Yeah, I need to do df. I need to get my condition and time column, and this is kind of splitting them up, splitting this up so that we actually have new columns, but are just called a new column just called condition and a new column just called time. That's trying to be defined. Let's see if I just where is that? So I think I've actually got that here. No, put that here. Need to use this. Okay. Add that straight line as well. The thing is, I've changed my keyboard's key bindings quite a lot, so that things like this are now included on my keyboards, whereas before I would have to add them in as symbols using some kind of third-party software. But I've changed that, so now my life is a bit easier. Yeah, I don't like how this is defined, so I'm gonna have to try and do a bit of troubleshooting. And that's because I forgot to close off my definition, which is why you always need to have these two, because otherwise take this guy off and it's still waiting for me to close my own defining of the column or the variable. So here it's found this as the closing um, of the defining of the variable, um, but that is not true for this case, and because I want to close it so that it's just this column, and now we have it so that it's registered as a function now, which is why I didn't want it looked a bit confusing before. Um, and this is kind of making the line quite long, so I will just, if I put a full stop there, I actually want to put a comma, um, so now I can specify my new, so this is creating a new column called condition, and this is now me creating a new um, column called time, where I am kind of just writing the same thing, but the only difference is I'm extracting not control and experimental, but Wingate um, and warm down. Uh, and yes, and actually after this I can also put in a print command. I believe they're called commands. Uh, that's not starting because I haven't closed it. There we go. And this is just me saying print off our new kind of formatted table that we'll be using later on. The formatted table within this variable that I've specified here. Um, and attribute assign. Oh, and that's because I've actually spelled the function wrong. So yeah, syntax errors, like always, they're the bane of using this. But once you know what to look for, they come out quite easy, quite nice. Okay. So we can see what was trying to be done is I've changed and formatted my table. So now these kind of condition time specifications for each um, measurement, specifying that this is a control condition, but Wingate test collected VO2 value. I've added them. They're still here. Um, but now I'm just splitting them up so later on when I do my ANOVA I can specify that I would like this factor with this factor to be analyzed, but here we can see that it's come out with nothing, which means that over here I need to just force it to understand that I want that Wingate. So you can see that that has fixed. That's another, our time condition is specifying whether or not it's the Wingate or warm down. And actually realizing now this has got an issue because it's only specifying the first um, 5 lines of the data frame. So actually, if we can, I can quickly do something so that we actually print the full um, line of code. Keep that in there. But now I'll actually use this to string function from one of our libraries. I've forgotten which one, and I'll have it so that it does not have an index, so it will show all the the values. This one and this one. There we go. There we go. So now we can see that all this has done has made it so that now for each subject, well, the subject is now, we can see that it's repeated along for each person, which is what we want. But now it's specified that this VO2 data collection for, let's say, subject 1 was when they did their control condition, and it's when it was collected during the Wingate test. And we can see here for subject 1 again that this VO2 measurement was collected once again through the control condition, but for the second part it was collected during their warm down, and like so for the rest of them. So this is formatting the table so that now it's easier to do our ANOVA, which we're gonna go into now. It's been a while since this recording has started. But now we're finally in the ANOVA where we have I'm creating a new variable, so where it will include the ANOVA data frame, and I've just called it ANOVA table. Don't even need that there, but for our ANOVA table, this will include our ANOVA repeated measures kind of function that we wanted, where we will have our long df variable, df variable, where actually we want to do this dependent variable, and we'll have that equal to our VO2 data. So we're specifying that our dependent variable for this ANOVA test is the data that we wanted to actually look at is this. Otherwise, it wouldn't know what to look at, and it might use this as our data. But of course, this is not even numerical. This is just specifying that. Yeah, and we'll have it so that we can. This is why we had it. We brought in this new subject column, so we can specify that our subjects are split between 1, 2, 3, 4, 5, 6, 7, and 8, and they're each identified by their number, which is in the column. And now we're specifying that is a within condition for these two conditions, which was our experimental and control condition that we have here, and our time condition or time column that I put there. And we'd like to fit that within our new ANOVA table, and this is just the function so that it's included within the table properly. And our next bit is actually we're going to be wanting to this next line of code is going to be trying to get the p-values and specifying that we actually want them rounded to let's say 4 decimal places. I can do 3 or others, but everything I've done here is to 4 decimal places, and I'll just keep it like that. But this is just saying for our p-values, um, let's p-values for our ANOVA table. Make them greater than our f value. Is it correct? Yes. Let's come out as a yeah. Round these values up to. This is our index. Ooh, that is just saying round them up to 4 decimal places. And then we can start up a line of code to print everything, so that we can get our data. And this is we're just printing our kind of we're creating a title now. This is all I'm doing now is calling it, so that a new table will be called p-values for condition, time, and interaction between the two conditions. I found that I had to put this and actually I need to put my my backslash. Oh, do I not have my backslash? Oh, I might have put my backslash on the wrong key binding. No, there we go. And then our string function. Don't know why that's trying to define everything still. Let's see if we can force it to give us our error. Okay, so unterminated string literal. So that's fine. N slash. Oh, okay. So the issue we've found here is as this the backslash is is used for escaping your quote. However, how I've done it is I've put my backslash after the N, whereas it should be in front of the N. Yeah. So now it kind of because you can't have your closing definition, your closing quote, right after a backslash, I mean an ending quote, because then it causes an error, which is why we put the end there, so that our closing definition, our closing quote, is on the n and not the backslash. So now we can run this again and get another error. So this error is saying that a function is not attributed to the ANOVA table, which it's saying in the first line at 17. That will be, so that'll be here. So far we've seen a lot of errors, but this is the raw experience as a beginner using Python. However, it is all worth it. And from what I've understood, specifically my function, specifying function means I've now got to look at the blues because these are all functions. And it says that doesn't have an attribute to the ANOVA table. Because it is trying, how I've written it here is stating that what my code is trying to do is access the ANOVA table directly from the .fit function. However, my .fit function is actually my .fit function, my .fit method, I mean, um, it's a method. So my ANOVA table does not exist within it. So I actually need to close off with some parentheses. I need to call it with some parentheses here. So now it does not try and attribute the ANOVA table with it. And this should, there we go, fix everything. Lots of trial and error and experience is needed. And here we have it, our p-values for the condition, time, and interaction. So where this is shown that well, the interaction between the two factors, that there was no significance. However, these are the ones that I really like to look at, where we can see between our experimental and control condition, there is a significant interaction and a significant difference with the two two VO2 measurements, and with time between data collected during the test and the warm down, there's also significance there. And yeah, that is how you perform a two-way repeated measures ANOVA, and how you format your data along the way in order for it to in order for you to be able to use the stats models library and its ANOVA function. There are, not to my knowledge, as I'm still a beginner in this and haven't got the amount of experience necessary to be educated. I mean, to have a very educated guess on this, but I believe that there are probably better libraries that are more optimized for doing this test. However, I have gone with the stats models library as I found a lot of community help with it. And once you get used to it, it isn't all too bad. Thank you for listening.